Today you'll be doing 5.1 solving and justifying linear equations. At the end of this lesson you will be able to solve multi-step equations and explain your steps when solving equations. Here are some of the steps to solving equations. Number 1, eliminate fractions by multiplying by the denominator. This is called clearing the fraction. Number 2, distribute using the distributive property. Number 3, combine any like terms on the left or right hand side of the equation. Number 4, get all variables on the same side. Number 5, undo any addition or subtraction, not touching a variable. And number 6, multiply or divide to isolate the variable. Here are the properties you will use to justify each step of the equation. In the next few examples, I will be using these to justify my steps. Example 1. Solve the equation and explain each step. First, I need to eliminate the fraction. So I'm going to multiply by 6 on both sides. So I get x minus 5 equals 24. And I will justify this step with the multiplication property of equality. Second, I want to undo the subtraction by adding 5 to both sides. I get x equals 29, and I justify x equaling 29 with the addition property of equality. Example 2, solve and explain each step. There are no fractions to clear, so I need to get the variables on one side and the numbers on the other. I'm going to subtract 4x from both sides. So I get 5x, carry the negative 11 down, equals negative 1. Don't forget to carry down the minus sign as a negative on the 1. I justify that step with subtraction property of equality. Next, I'm going to move the 11 over, adding 11 to each side. And I get 5x equals 10. I'll justify that step with addition property of equality. Finally, I'll isolate the variable using division. Divide by 5 on both sides. I get x equals 2. Justifying that step with division property of equality. Example 3, no flat fractions to clear, but I do need to distribute the 4 and the 2. Distributing the 4 gets me 4y minus 8 equal to, distributing the 2, 6 plus 2y. Now I'm going to move the variables to one side and the numbers to the other. Subtract 2y from both sides. I get 2y minus 8 equals 6. I'm going to justify that step with subtraction property of equality. should be 8 over, add 8 to both sides. So 2y equals 14. I'll justify that step with addition property of equality. And finally, isolate the variable by dividing by 2 on both sides. So y equals 7, and I justify y equaling 7 with division property of equality. Now in example 4, I'm going to circle the next step in solving the equation below. So as I look at this, 5x minus 6 equals 19. 6 was added to both sides using the addition property of equality, so that I have 5x equals 25. So my next step, divide by 5 on both sides, which is answer D. Example 5, same situation, circle the next step in solving the equation below. 4x minus 2 times the quantity x plus 1 equals 37. The negative 2 was distributed, so that the next step is to combine like terms. So B is the answer. Example 6, find and explain the mistake in the work below. Then solve the problem correctly. X plus 16 equals 4x minus 5. First step is done correctly. Minus 4x from both sides. Subtraction property of equality. But then the next step, it is already a plus 16, so it should have been a minus 16 on both sides. So when I redo the problem, from that step, negative 3x plus 16 equals negative 5. I'm going to subtract 16 from both sides. So negative 3x equals negative 21. And then divide by negative 3. So that x equals 7, not 11. Example 7, find and explain the mistake in the work below, then solve the problem correctly. First step, I notice I need to distribute. And in that next line, that's where the mistake is. It should be 5x minus 5. The 5 needs to be distributed to the x and the negative 1. So when I redo the problem, I get 5x minus 5 equals x plus 3. If the x is on one side, the number's on the other. So subtract x from both sides. 4x minus 5 equals 3. Add 5 to the other side. 4x equals 8. Isolate the variable by dividing by 4 on each side, and x equals 2, not 1. Example 8. This is your introduction to proofs. You'll do proofs next year in geometry. Every proof has a statement and a reason column. The statements are where your work go. The reason are where your justifications go, just like we did in the first couple examples. In any proof, the first statement is always the given. You rewrite the problem. 15 equals a over 3 minus 2. And your first reason is always given. And then you can start working it out. So I need to add 2 to both sides. So 17 equals a over 3. And my reason for that step is what I did above it. I did addition property of equality. The next step to solve, it is a divided by 3, so I need to multiply by 3 on both sides. I get 51 equals a, and my reason is what I did above, multiplication property of equality. And it matches my proof, so I know it did it correct, so I can put my therefore dots. 3 dots in the shape of a triangle. Example 9. Another proof, just a few more steps. Always begin by rewriting the given. 6x minus 4 times quantity 2x plus 1 equals 12. Your reason is always given. Step 2 is where you start working the problem. I notice I need to distribute the negative 4. The sign stays with it. So now I have 6x minus 8x minus 4 equals 12. My reason is always what I did above, which is distributive property. Next step, I notice I need to combine like terms, the 6x and the negative 8x. So I have negative 2x minus 4 equals 12. That is not addition property of equality or subtraction property of equality. Just call that combine like terms. Next step is to start solving. I'm going to add 4 to both sides. So negative 2x equals 16. My reason is what I did above, the addition property of equality. And finally, isolate the variable by dividing by negative 2 on both sides. So x equals negative 8. The reason for that is what I did above, division property of equality. And it matches x equals negative 8, what I had to prove, so I put my therefore dots. Now we're going to jump into just solving. Not a proof, no justification, just solving. But what you'll notice is there are fractions now. So I always want to clear the fraction so I don't have to deal with it. I look at my denominator and notice it's a 5, so the least common multiple of 5 is 5. So to clear the fraction, I'm going to multiply everything by 5. So 15 over 5x minus 5 over 5 equals 10. Now I'm going to reduce my fractions. 15 over 5 is 3x. 5 over 5 is 1. 10 stays 10. Now I'm going to solve it. Add 1 to both sides. 3x equals 11. Then isolate the variable by dividing by 3 on both sides. So x equals 11 over 3. That is the exact answer. 11 does not divide evenly by 3. Do not put a mixed number. And do not put a decimal. Leave it as the exact answer. Example 11, another fraction, but you have the fraction on both sides. You still want to look for that least common multiple of the denominator, which is 3. So every part of the equation must be multiplied by 3. 3 over 3x minus 12 equals 6 over 3x plus 15. I can reduce my fractions. 1x minus 12 equals 2x plus 15. And now I can start solving. Move the x's to one side, numbers to the other. Subtract 2x, subtract 2x. So negative 1x minus 12 equals 15. Add 15 to, or add 12 to the other side. Negative 1x equals 27. Divide both sides by negative 1 to isolate the variable. So x equals negative 27. Now we have parentheses. We still want to eliminate that fraction. So the least common multiple of the denominator is 8. So I'm going to multiply by 8. But when you have parentheses, you do not multiply into the parentheses. Do not distribute anything into the parentheses. We only want to do the leading coefficient. So 8 times 5/8 is 48. Leave the parentheses alone, negative x plus 7. 8 times 4 is 32. Leave the parentheses alone, 1 plus x. Reduce your fractions. 40 over 8 is 5. Negative x plus 7, leave it alone. 32, 1 plus x, leave it alone. Now that you've eliminated your fraction, you've cleared it, is when you distribute into the parentheses. Distribute the 5. So negative 5x plus 35 equals 32 plus 32x. Move the variables to one side, the numbers to the other. Subtract 32x. Subtract 32x. So negative 37x plus 35 equals 32. Subtract 35 over. Negative 37x equals negative 3. Isolate the variable by dividing by negative 37 on both sides. 3 does not divide evenly by 37, so the only thing you can do is cancel out the negatives, and x equals 3 over 37. In this last example, example 13, we have a combination of both parentheses and fractions. We still want to clear the fraction by finding the least common multiple of those denominators. And in this case, it's 4. On the left-hand side, I only multiply the 4 by the 3/4. On the right-hand side, both items get it. I don't touch the parentheses on the left. So I get 12 over 4 times 2x plus 1, not touching the parentheses, equals 4 over 2x plus 16 on the other side. Then I want to reduce my fractions. 3 parentheses 2x plus 1 equals 2x plus 16. Now is when I distribute into the parentheses. 6x plus 3 equals 2x plus 16. I want to move the variables to one side, numbers to the other. Subtract 2x. Subtract 2x. 4x plus 3 equals 16. Subtract 3 to the other side. 4x equals 13. Isolate the variable by dividing 4 to both sides. 13 does not divide evenly by 4, so I leave it as the exact answer. X equals 13 over 4.